All right, so we're going to use Kirchhoff's laws to analyze a circuit. These are circuits that are a little bit more complex than you can use Ohm's law for. And so the first of Kirchhoff's laws is the junction rule, and that just says that the current going into a junction, any place the wire split into two different paths or more, is going to be equal to the sum of all the currents coming out of that junction. So in this case, looking at the illustration, we have I1 current going in. It splits into 2 and 3. So I1 is equal to I2 plus I3. And then if you look down at part E, current 2 and 3 come back together to make I1 again. And this all comes out of conservation of charge. So that will give you one equation. And then how you get the rest of the equations, because these are going to end up being systems of equations with multiple unknowns and multiple equations, is called the loop rule. And what that means is the sum of all the voltages around a loop of a closed circuit are equal to 0. And so batteries are going to give you an increase in the voltage, and then the resistors are going to give you a voltage drop. And so going around this, if we started at C, it would be a drop across R2. So it's going to be a drop across R2, and then it goes up to the battery, and it's going to add that battery in because we're going from the minus to the plus side, and then it's going to drop at R1. And it looks like there's two R1s on this picture, so we're going to drop at the second R1, and it's going to end up being 0. So the problem-solving strategy is this. You're going to label all the points in the circuit diagram to help with direction, keeping track of where your loops are and what you're talking about. Label all your resistors, label your currents. You're going to find the junctions where the wires connect, choose your loops, identify the current direction, because you're going to need to know when you're going with the current direction as you're going around the loop. Resistors are going to take off the voltage, and when you're going against the current, you're actually going to add those in, and you'll see that in the example. And then you're going to apply the junction rule to find out where the current split, and then you're going to apply the loop rule. Okay, so we're going to analyze this circuit using Kirchhoff's laws. And because this circuit's got two batteries in it and basically two different loops, third loop if you consider the outside one, you really can't use Ohm's law straightforwardly to find out what the value of the currents are in each of the branches of this circuit. But we can use Kirchhoff's law, and we'll start off with the junction rule. When we look at B, little spot B on the circuit, you'll see that you have one current coming in and two splitting out. So that's our first equation. We have I1 is going to be equal to I2 plus I3. Nice and straightforward. And we could use point E, same idea, but we don't need to use both. It's not going to give us anything different. If we used E, it would be I2 plus I3 is equal to I1. So that doesn't help us. We're trying to get three equations and three unknowns. So our next one is going to be our first loop, A, B, E, F. And so we're going to start at A, and we're going to go through our first resistor. And so the voltage drop across that first resistor is minus I1, R1. We're going to turn the corner, and we're going to go through R2. So we have minus I2, R2. And we're going to turn the corner, and we're going to go through our battery. And so this should be voltage 1, voltage 2. And so we're going to end up with that going all the way around the circuit is equal to 0. And then we want to look for a third equation. And for this one, we're going to start at point E. And since our loop, if we're going from E to B, our loop is going to be going the opposite direction of our current flow. This is going to be positive, I2, R2. And now we're back to in the flow again. And then we have I3, and it's going to go through R3 and R4. And then we come back to our battery, and instead of going in at the negative terminal, we are coming in at the positive terminal. So we're going to subtract off our voltage. So those are our three equations. Our unknowns are current 1, 2, and 3. You can chug through this however you like. If you don't like my method, there are lots of other ways to solve three equations and three unknowns. But it's going to be somewhat brute force here. So we're going to start. All right, we have some values for these numbers to help us slug through. Otherwise, we have way too many unknowns. So here we go. Working with equation 2 first. We don't know what I1 or I2 is, but we do know R1. So minus I1 times the 3 ohms minus I2 times the 3 ohms plus 6 volts is equal to 0. And if you work through that one, I1 is equal to minus I2 plus 2. And then you can plug that. I'm going to plug that in. Plug that back into your first equation, and you get minus I1 plus 2 is equal to I2 plus I3, and you end up with I3 is minus 2I2 plus 2. And then you want to take that value and plug it in to I3. So we get I3 all in terms of, or equation 3, all in terms of I2. So we have I2 R2 minus negative 2I2 plus 2 times R3 plus R4 minus V2 equals 0. We have values we can play with here. So we have I2 times 3 ohms minus negative 2I2 plus 2 times 7 minus 9 volts equals 0. All right, so continuing on and kind of simplifying things a little bit, we have 3I2 plus 14I2 minus 7 minus 9 equals 0. And if you work through this, you end up with I2 is equal to 0.9 amps. Plug that back into the other equation with I1 and I2, and we end up with minus I1 times 3 minus 0.9 amps times 3 ohms plus 6 is equal to 0. And if you work through all that, you get I1 is equal to 1.1 amp and since I1 has to equal I2 plus I3, I3 ends up being 0.2 amps. So you can see there's no way we would have gotten through this with the two batteries any other way. But this is how you go through and solve these types of circuits out with Kirchhoff's laws.